I suppose all of this sort of begs the question then, what's a flood? We've been talking about mechanics of the rivers for a while, but our theme here is flooding. So this is a cross section of a stream. So imagine you're in the water, floating happily and looking maybe downstream here. Right here, you can see those natural levees that we talked about earlier. So if we're going to measure this here river, to get the discharge, we're going to measure the depth of the water, we're going to measure the width of the water, and we're going to measure the velocity. This is supposed to be like an arrow moving at us or coming away from us. It's one of the ways to show kind of that third dimension there for you. So that gives us the discharge of the river. But if you notice, there's more river channel there. So we can also look at just how high the river channel goes, or the complete depth of the river channel versus just the depth of the water. So what we can do is we can imagine that is the very highest point that the water can rise to without overspilling. And so this is an important measurement for us. So what we can calculate here is what we call a Q max, the maximum discharge that this stream can hold for a given velocity of water. And so that H is an important measurement there for us. And so we can look at this a couple different ways. So how do we define that this particular river is flooding or not? So in this case, our Q max is greater than Q, which means the depth of the water is less than the depth of the channel. So there's no flood. Over here, our Q max is less than Q. So how much water it can hold is less than how much it is trying to hold. And you can see that water is spilled over the sides here. So Q max less than Q results in a flood. Now, sometimes those are equal. Q max equals Q. We call this a Bankful Flood. And this happens about every couple of years for most rivers in a completely kind of natural environment. So every couple of years, a Bankful Flood will happen. So let's talk about this 100-year flood. This is a term you've probably heard before. I'm going to cheat, and I'm going to play you a little video because he does a better job than I do.
Now, we've all heard the phrase, a 100-year flood, but what does that actually mean? Well, one of the first things to acknowledge is that it's a little complicated, but we will do our best to explain it. To start off with, there's a common misunderstanding that if a 100-year flood has occurred, then it'll be another 100 years before we see a flood that big again. This is a misunderstanding that has arisen over time due to slightly misleading terminology. If you were to ask a hydrologist or engineer what a 100-year flood was, they would say that it has a 1% annual exceedance probability, or AEP. In simpler terms, there is a 1% or 1 in 100 chance that a river will see a flood of that size or larger per year. To further understand this, consider rolling a dice. With every roll, we have a 1 in 6 chance of rolling a 6. We also know that we have the same chance of rolling a 6 every time we roll the dice. So just because our last roll was a 6, it doesn't mean we won't roll another 6, or that after 10 rolls, we won't have rolled 1 at all. The same is true with floods. Unfortunately, if there was a 100-year flood this week, it doesn't mean that another one won't happen for another 99 years. In fact, it could happen again this year or next. Another issue that often causes some confusion is why the return period of a flood changes over time. You may have heard of a flood being called a 100-year event when it happens, but later it's referred to as a smaller event, such as a 50 or 80-year flood. This is because our understanding of the size of an extreme flood is based upon a statistical analysis of those that we have previously seen on that particular river. Every time there is a flood, we gather more data that gives us a better understanding of how big floods in a certain river might be. We use that data to determine what size the current flood is, and if it's bigger than anything recorded on that river before, it may influence the current estimation of flood event levels. For example, what was previously considered a 100-year event may be downgraded to an 80-year event, This is particularly noticeable in many New Zealand rivers where we don't have a long history of recorded floods. It is also worth considering the fact that our estimation of how big a 100-year flood might be is based upon floods that we have seen before. This means that it is likely to change in the future, especially when factors like climate change or changing land uses are considered. So, a 1 in 100-year flood means there is a 1% chance of a flood of a certain size happening in a river in any given year. That 100-year size is determined by historical floods on the river and may change, especially with factors such as climate change and weather patterns added to the mix. Fortunately, these are relatively rare events, but when they do happen, it is helpful to understand what the terminology means.
All right. So what this means is that recurrence interval, we only know it with a certain amount of certainty. If we had 1,000 years worth of data for a stream, we could probably figure out that recurrence interval fairly well, at least for that 100-year flood. But as you saw in the Grand Canyon, we only have 95 years worth of records. And so estimating something like a 100-year flood is pretty hard to do there. And any kind of rare event that's particularly large or particularly small is going to affect what our recurrence interval charts look like for that particular place. So, they mentioned in the video that a 100-year flood doesn't happen every 100 years. It could happen 2 days in a row under really unfortunate circumstances. So the town of Wyndon, Arizona, is just to the west of Phoenix, I believe. Wyndon had 100-year floods in 2000 and 2010. And so it's not exactly like these don't happen very often. In this case, they ended up having to evacuate the entire town. And there was multi-million dollars worth of damage done in 2010. Like I mentioned earlier, 2010 was a nasty year for floods.